scatter plot. Okay? Before I go anywhere, I like to go into my y equals and make sure I don't have any extra equations in there because they turn out kind of goofy. And so I was showing somebody about a limit, I think. Maybe myself about a limit there. All right. So I make sure my y's are all cleared out. And then if you do hit the zoom key, number 9, zoom stop. You don't have to arrow down to it after a while. You just hit the number 9. You know which one it is. And bada bing, bada boom. There is the same plot that I have on my paper. It, of course, doesn't have the scale and the labels, but it gives me a general idea of what my scatter plot looks like. So I did a zoom 9. Okay. Anybody not be able to do that? Okay. So if you need to go back to these, I should have the recording for you if you need to go back and review how to put these into the calculator. All right. So next thing I'm going to do, I'm going to go back to my paper now, is I am going to measure the strength of this relationship. By a measurement, that says strength, sorry, by a measurement called correlation. A correlation also measures direction. Okay? So, to measure the strength with this thing called correlation, that is a variable that we always call R. And R is a number between -1 and 1. And if R equals -1, then the points are in exactly a straight line with a negative slope. And if R equals +1, that means all those points in the scatter plot are in exactly a straight line with a positive slope. And if R is equal to 0, then there is no straight line association or relationship. There may be a curved relationship, but there is no straight linear, there's no linear relationship. Okay, now, yes. Oh no, it can be any number in between. So it mostly will be a number in between. Rarely are you going to get a -1 or a 1. So we're going to kind of measure our strength by how close that number is to -1 or 1. Or if it's very close to 0, we'll say, oh, this isn't a linear relationship at all. Try to model. Yes, sir? It gives a correlation of 0 because of the way the calculation is done. But it is exactly a linear relationship. It's just that the linear relationship ends up being the same as the mean of the response variable. So it ends up being kind of not a interesting relationship, but certainly can happen. And when we get a little further into inference, we look at testing the relation, testing whether the slope is 0 or not. And so that, how close is this relationship to just the mean of the response variable. Okay. R is a number that is calculated. Sorry, went over your heads. That's okay. We'll get there. All right. Formula. 1 over n minus 1 times the sum of each one of the numbers in my X list. Right there. I call that X of I. I am going through LES like nobody's business here. Minus the mean of the X list divided by the standard deviation of the X list. Okay? Times each one of those numbers in the Y list of the responses minus the mean of the responses divided by the standard deviation of the responses. Okay? This is why we're doing a short list today. We're going to work through this calculation one time. You'll work through it one time on your homework. And then, of course, what will you use to calculate R? Your calculator, yes, obviously. Okay, so let me find out all these different measurements. I need to know what N is. N is the number of pairs that we had in our XY list. How many pairs did we have? We had 5 pairs. Okay? And I need to know the mean of my X list. How do I go to find that? 1 var stats. So stat, calc, 1 var stats, and I need my X list. That was list 1. That's the default, but you can put it in if you want. And that gives me a mean of 7.01. And I also need the standard deviation, and we'll use the sample standard deviation of 0.46. Okay? I also need the mean and the standard deviation of list 2, the responses. So I'm going to go stat, calc, 1 var stats, and I can go second 2. You could have gotten this from 2 var stats too. It puts it all together for you, but this is fine. And get a mean of 67.1 and a standard deviation of 3.86. Okay. Now I plan on doing some nasty calculations. Then we're going to see if it verifies what you get out of your calculator. Okay. So here I go. Got to be able to read my numbers here from earlier. Okay, so R is 1 over n minus 1. 1 over 4. Times. I'm going to sum, so I won't put that summation symbol anymore. X sub I, the first X was a 7, minus the mean, divided by the standard deviation, times my first Y, 68, minus the mean, divided by the standard deviation for the Y list. Plus my second number, 6.5, minus the mean of the X's divided by the standard deviation of the X's, times the 62.5 minus the mean of 67.1 divided by the standard deviation. Okay?